Hello, everybody. My name is Nicolas Schmidt. I'm going to be presenting an intro to Three.js, and we're going to be building a really simple animated diagram from a 3D model that we can display in our web browsers. I want to say thank you to Thornton Tomasetti for putting this on, Core Studio. We have Joran Jensen and David Manns with us today, and they're going to be helping out in case there are any confusions you guys might have. You can reach out on the Slack and they'll be able to answer some questions, particularly at the beginning with setting up your environment. So hopefully everything goes smoothly, but if you need a little hand, they're there. So I just wanted to start off by introducing myself. My name is Nicolas Schmidt. I'm a BIM manager at Ennead Architects and a web developer. And I presented this year at SIGGRAPH. I presented a interactive drafting app in the browser. Images from that are on the right. And then I also created a axonometric kind of rendering model viewer. The image that represented by the image in the middle. So that's kind of what this class is based on today. So first things first, I hope that, so the first thing to be able to run this project and to follow along with the tutorial today is to install Node on your computers. I hope that most of you have had a chance to do that already. If you haven't, I think that would be a good thing to reach out to Dave or Joran about. It's pretty easy to install as long as you have administrator access on your computer. Okay, so I'm going to suppose that, or I'm going to assume that most of you all have done that. The next step is to install Budo, which is a package that's going to allow us to serve our app on our local machines. So yeah. So we're not doing any. This is the only npm package that we're going to be using. It's really nothing fancy. The command to install it is npm-i for install -g for global Budo, and then you'll be able to run the script and serve the application. The next step that you guys need to do to be able to run this is to clone the repository. So I put the link to this in the Slack channel. So if you go to that address and clone the repository, you should be good to go. And then to run the code, it's budo --dir for directory period, indicating the current directory, and then --live. And that'll give us some live reloading. So as we're developing, we don't have to constantly restart the server every time we make a change. Okay, so hopefully that's relatively clear. I think one thing that I didn't put into the chat is this script to run the code. So I'm going to actually do that right now. Yeah, I'm going to be working today on a Mac. So some of the things that some of the commands might be a little bit more Mac specific, but hopefully once you get to the proper directory, get npm installed, and run Budo, it will everything will be working fine for you. Yeah, so let's get into it. Hoping that you guys have your directory set up. Is there anybody who's having problem getting their environment set up? Okay, like I said in the Slack channel, this is, following along is optional. I think you guys will get a lot out of this, even if you're not able to. But it might be fun for you to play around with the code while we're talking. So yeah. So without further ado, let's just get into it.
Can you send the link to the repository again? Sorry.
Yeah. Sure.
Or something? Thanks.
Yeah.
I'll take care of that.
Okay, thanks, Dave. Or Joran. Okay, great. So what are we building today? We're going to be building a very basic web viewer. So getting into how to display 3D geometry in the browser using Three.js. we're going to be loading a model using Luis's 3DM loader, which is going to be really fun because we all love Rhino. So that'll be great to learn how to do that. Oops. Here. So all of this is going to happen in a canvas. So canvas is an HTML element, and that's going to be where all of our geometry is rendered. Typically, when we talk about web development, a lot of people first go to what framework are you using. React, Angular, Vue, Mithril, all these frameworks that we really love are really great for helping make transformations in the HTML DOM really efficient, but they don't really have anything to do with what happens in the canvas. So for today, we're just going to focus really closely on Three.js and what's happening in the canvas. So we're not going to worry too much about all of the kind of complexity that can be introduced by like JSX and all of these other kinds of pieces that you need to know when. It's just going to be like writing JavaScript and dealing with the Three.js API. Okay, so this is kind of what the app is going to look like on the right. There is a simple model that I've included with the repo, which is this kind of Mason domino kind of thing. We're going to have a couple of UI elements, including a slider at the bottom to explode or displace these elements. We're going to have a little context menu that's going to allow us to modify attributes of these elements. And we're going to have a button that will allow us to take a screenshot. And the way that we're going to do this is I'm going to share my screen with code on the right and my browser on the left. And I'm going to kind of walk through the code and uncomment sections and talk about what they're doing to implement these different features. If you clone the repo, the master branch is going to have like a full working version of this app. There's a branch called class. So the way that you change branches is git checkout class. CLASS, and that is going to take you to a minimal version of the app. It's going to still display the geometry, but you're not going to have any orbit controls. You're not going to be able to hover and change attributes or displace the geometry in the model. So we're going to go through and implement those things together. Yeah, so this is basically what I just discussed. We're going to clone the repo and start our development server. So hopefully you guys are getting that going. We're going to review the code and the features that we're going to be implementing. The first main feature is using the 3DM loader to get our Rhino model loaded into our app. And we're going to look at some cool ways that Rhino is actually going to pass geometry to our app. Or we're going to be able to access attributes on some of these elements from Rhino, I should say. We're going to add orbit controls. This is going to be surprisingly easy, given the given the necessity and power it gives you. We're going to look at automatically calculating some displacement paths. So what direction do we want this geometry to move in when we explode the axonometric diagram? Then we're going to look at selection and modifying attributes. So, and then finally, just adding a screenshot feature. So just the biggest time chunks here are going to be number 3 and number 6, selection and modifying attributes. The other ones are going to be very useful and interesting to take a look at, but they won't take up as much time. Just to give a really quick overview of what this app is going to look like I said, it's a very simple web app where we have just an index.html where all of the DOM lives. We have a couple of CSS files that style those elements, and we have 2 main JavaScript files. One is the Axon Viewer.js, which is where we're going to be spending most of our time today. And then we have the context menu.js, which controls that context menu element. And we're going to pass some JavaScript objects to context menu from Axon Viewer using ES6 modules. We're also going to be bringing in a couple of outside resources. So we're going to be bringing in material icons because I like material icons, and it'll make our UI a little bit more legible. And then we're going to be bringing in orbit controls in Three.js from a CDN, from a link. So you can have those included with your app, but just for the simplicity's sake for this class, I thought this was a better way to do it. Okay, so before we really get into the code, I just wanted to give a brief overview of what this scene is going to look like. So this is a Three.js scene. And what that means is a tree structure, like you might have seen in other 3D modeling apps. Basically, you have the scene is a top-level node with all of your geometry, lights, and cameras underneath. We're going to have a few different lights. Then we're going to have a node called Rhino Dock, where our Rhino geometry is going to live. That's where we're going to put everything that comes from the Rhino file in this node. And that's kind of the way it happens naturally with the 3DM loader. Underneath that, we're going to have some object 3Ds, which is a Three.js object that that holds other geometry and can be kind of this an arbitrary node in your scene graph, which is what the structure is generally called. Then there are also some meshes, which are kind of like object 3Ds, except they have geometry and they don't have any children, so no geometry underneath them. So, and we'll take a look at what impact this has on our code in a few moments. We'll look at this again when we get into actually implementing some of these displacement paths, but it's just some very simple vector math to calculate those. So yeah, so I think that kind of concludes the slides. We have a couple more slides we'll go through at the end. But I think we should get into the code. So does anybody have any questions or anything that they'd like to say before we get started? Okay, great. Yeah, so first of all, let me just switch over to the master branch and I can show you guys oops, sorry. Switch over to the master branch here and show you guys what the working app is going to look like. So we have a 3D model loaded in from Rhino. You can, I can use my mouse, and if you run it, you can also use your mouse to orbit around the scene. You can highlight an element and we get a sort of a highlight state when you highlight to indicate what you're about to select. You can click on an element and there's a selection state. When you have something select, you can select multiple things. You can deselect things. You can select something and then deselect it. You can select it and you can open up your contextual menu here and have a couple of different parameters that we can change on this object. So, and we'll go into that a bit. And then the fun stuff is we can explode our diagram here, and then we can take a screenshot. So, and we'll implement each of these features. Yeah, zooming, everything. So that's great. So now that you've seen where we're going, let's take a look at where we're at. So I'm gonna say git checkout class. And so that's gonna switch our branch to the class branch. And then I have to rerun Budo. And I can reload this here. So one thing to know is with Budo, it's not gonna automatically refresh your page with this setup. So we won't have to restart the development server, but you do have to refresh the page. So that's just a minor inconvenience compared to restarting the server and rerunning it, which is also a minor inconvenience, but they add up. Okay, so now you saw what the app we are building is going to look like, but this is what we have. So our slider here is disabled. This button is not going to do anything. We don't have any of the hover states or selection capabilities. So we're going to go through and build that together now. The first thing I'd like to talk about is just a basic setup of Three.js. So this is going to be yeah, so this is really just basic stuff here. So first of all, like I said, we're importing 3 and orbit controls from Unpackage, which is a content delivery network. So we're going to be able to use these without having to actually include them in our folder structure and commit them to GitHub or whatever. Anyway, so yeah, so the first thing, we're going to start with init, start with 0 here. And basic setup. The first thing we need to do is we need to get our canvas. Like I said, Three.js and WebGL renders everything on a canvas. So, so that's this kind of floating element here, and it's not like you have, you know, divs and paragraphs and whatever making up these faces of this geometry. It's all just geometry being rendered by a 3D renderer on a single element, which is this canvas. So anyway, so this canvas is going to come up a lot, and it's a good thing to just have a little awareness of. Great. So we're going to set up our renderer, which is what is actually going to draw these beautiful polygons for us. We're going to set up a clear color, and we're going to create our scene. So this scene, new 3.scene, is what's going to create our scene graph. This is that top level node in our tree structure, and all of our geometry, camera, and everything else is going to come after that. And you'll see a lot of things like this here, scene.add, where we add things to the scene. The only thing that we don't actually have to add to the scene, I believe, is the camera, even though it is sort of technically underneath that. They pretend like it's not, I think. So because we want to make an axonometric diagram today, we're going to be using the orthographic camera, which I love axons, and you know, some of the impetus for this project that I started a while ago was just some, you know, beautiful axonometric diagrams that we've all seen from mid-century modernists and et cetera. So it's actually, I think, really interesting to us as architects, the way that, you know, the orthographic camera versus a perspective camera works. So I just wanted to switch over and take a second to show you guys the Three.js documentation. This is obviously an invaluable resource when you're working with Three.js, and it's really amazing. They have it's very well documented, and then they have examples that show everything. I'm like particularly fond of the example showing the 2 different camera types here. So we have on so right now we're viewing this as a perspective camera, and you have what is being seen here, and then you have a sort of third-person view of the camera and the scene. So if we switch this over to an orthographic camera, you see how that changes. So what we have here is basically a box, and everything inside that box is going to get rendered. It's pretty simple, and it produces this parallel projection that we really like. Now, one thing to note is the way that this green ball is kind of coming in and out of our view here. And the reason for that is it's passing behind this plane, in and out of this plane, and that's what's called the frustum. So the back frustum, and I'm sure you guys are familiar with the concept from other software. So when we set up our camera here, we actually set up the left, right, top, and bottom of this box, and then we set up the near and far frustum. So that's what this 20,000 is. I just made it really far in the distance, so we won't have that problem where things come in and out of view. The other thing is we want to set the camera position, and even though you might think that the camera position doesn't matter as much with the orthographic camera, you still need to make sure that it's actually like in front of it's far enough away from the scene that it can view what's going on. So that's what we're doing there. Okay. So let's see. Then the next really critical things for setting up a Three.js scene are going to be our animate and render functions. So the render function is where the scene is actually rendered, and that happens down here. So render.render scene camera, and then that is called in the animate function here. So we call yeah, this animate function is called on every frame. So whenever the browser decides it's time to render another frame, it will call animate, and animate in turn calls render. And you can see as we go through this, we're actually going to be doing a little bit more in animate as well, to implement some of these other functions. Okay. So in addition to the ortho camera, which I really like, I want to talk about one really nice feature of Three.js that helps a lot when you're creating when you're developing Three.js apps. So, and they are these helpers. So in this example, we see this orange box showing the camera view. And that's an ortho camera helper. And what that does is it kind of gives you something to refer to in your 3D scene as you're adding geometry, if you want to know where your origin is, etc. So if we flip back over to Axon Viewer here, you can see, and I keep trying to rotate my view, but I can't yet. But you can see this bright sort of thin green line and a blue line going vertically. That's actually what's called an axis helper, and that is allowing us to kind of see the XYZ origin and those three axes, so that we just to help us know where the 0, 0 point is. I think right now is actually a fine time to just show you that this is really coming from a Rhino file. So, so this is the Rhino model, and you'll see that the colors actually match what we're seeing in our browser. The other thing, and we're gonna look at how to match those, how to get that data out of this file. One other thing that matches, and this is something that we don't have to do anything about, and I'm sure you guys have seen this before as well, but the origin point in our Rhino model actually matches with the origin point in the Three.js viewer. So if you note, it's right here, kind of underneath that second stair landing. So, and then it's in the same position here. Now, let me see. So yeah, so then one final thing, just with basic setup, one thing that you really need to be aware of is what happens when you resize the camera, or sorry, resize the canvas. So right now we have it set up pretty nicely so that it behaves in a way that feels natural. But you can imagine that there are a lot of other ways of doing that might not. You could stretch the canvas, or you could zoom on. You could kind of end up looking at a very small part of the canvas. And I think that this is a good opportunity to introduce another really great resource. So in addition to the Three.js documentation, there is a website that I love called Three.js Fundamentals. The guy who's written this is a contributor to Three.js. I think he's actually a Chrome developer. He has a series on Three.js, on WebGL, and it's very well written. And if you guys are looking to learn more about Three.js, or even just build an app and learn at the same time, I would definitely check this out. So, and this is where some of the code comes from today. So I'll have like a little a link to that where it's something from this site. But he has a really good implementation for resizing canvas. So we can just take a look at that quickly in the render function. So here, resize render to display. This will take a look and see if we need to resize the window and handle it accordingly. One thing here that is a little bit different than what you might find online is that we're dealing with an orthographic camera. So like I said, the ortho camera is not as well sort of supported. People don't like it as much as I do. And mostly people deal with the perspective camera. So documentation that you see online is going to typically focus on the perspective camera. So here we have to do some things to resize this box. And we basically want this box that the ortho camera renders to be the same size as our canvas. Yeah, so that's a really important thing to note, especially when dealing with the orthographic camera. Okay, so that deals, I think, with our basic setup. So just to recap, you need to have your canvas and renderer, and the canvas is an HTML element that actually gets assigned to the renderer. We have a scene graph, and we created a new Three.js scene, and a camera. We have some lights, and we can talk about that in a moment. And then we need to render and animate our scene. And then finally, when creating a Three.js app, you have to really look hard at what's going to happen when the canvas is resized. So that's where we're at. Let's see, I'm seeing some chats come in. Okay, great. Thanks so much, Dave and Yaron. Okay, cool. So the next thing I'd like to start talking about is, I think we can get into some of the fun stuff, which has to do with loading the geometry from the 3DM file. Yeah, so let's get into that. So the way that we do that is through a pretty typical pattern for Three.js, where we have a loader, which is something that you'll see in Three.js, and then we have our model here, and we call a function called load model from this loader object. One thing that's a little bit different about the Rhino 3DM loader than you'll see in other Three.js loaders is there's this additional set library path call here, and we need to actually point our loader to a separate Rhino 3DM file here. So I think we'd have to talk to Luis to know exactly what's going on here, but I think that they've taken some of the meshing code in Rhino and compiled it to WebAssembly. So that's actually really cool, and it allows us to take these breps and NURBs and turn them into meshes that we see on that we can render in the browser. So then we will find our model and call load model. So that looks pretty simple. Let's get down to load model and see what's really involved here. Let's see, make sure everybody's going okay on the chat. So in our load model function here, what we're going to do is we're going to take an object and we're just going to call it RhinoDoc. Currently, I'm printing this, so we can actually take a look and see what this object looks like. This is an object of type object 3D, which is one of the main types in Three.js. This is a complicated object that basically represents one of those nodes in our scene graph. So it's a parent object generally of other geometry objects. And this parent-children terminology is not just something I'm making up here. It's something that is represented in the code here. So we have children here, which is an array of all of the different geometry, and you'll see object 3Ds. Which also have their own children. So this can become a very deep nested structure, or it can be a shallower structure where you have these mesh objects which has its own geometry. So that's something that we're going to need to keep in mind as we take this geometry and load it into our web viewer. So the next thing you might notice here is we have a line rhinodoc.name equals rhinodoc. So And you can see here, name RhinoDoc. So we're actually giving this, this object a name. Name is a property that Object 3D has naturally, and we're going to give it our own name just so that we can we can access it quickly. The next thing we want to do is we actually want to get the material from the Rhino model and assign it to the geometry in our Three.js viewer. So the way that we do that is by getting the user data. So we're gonna iterate through all of the children in this big RhinoDoc object, and we're gonna access some information that actually came from that Rhino file, that 3DM file. So if we just take a look here at the console, we can take a look at this, what all the data that we get in from the Rhino model is. So we're looking at children here. So we want to get information on the children, and we're going to look at the user data. And then user data.attributes. So attributes is where the information is coming from the Rhino model. So we have a lot of different stuff here, and you can actually use any of this to, you know, in however, whatever way you see fit. But this is, it's super useful. And what we're going to access here is this draw color. So this actually gives us the same color that we were just viewing in the actual Rhino file. And we're going to be able to, and we're going to be able to just want to get a little more screen space there. So, and then we're going to be able to actually assign that color to the geometry in the Three.js viewer. So we get the color from userdata.attributes.drawColor, and then we create a new material with that color and assign it to the geometry. Yeah, so one thing that you'll note is that we have a few, if you look at the code here, we have a condition here. And we're actually going to need to look at these meshes that aren't parented to a Object 3D a little bit differently than the Object 3D objects. And the reason for that is because we actually have to operate on the geometry itself for a lot of these things. So for instance, to add a material to the geometry, we actually have to get we have to get to those polygons and assign a material. We don't have to get all the way down to the polygons, but you have to assign it to the mesh itself. So if we look at our mesh object here, we have a material. If we look at our Object 3D, you'll see that there is no material. So so we either need to just assign a material to the mesh, or to again loop through the children and assign the material to those meshes there. There's another maybe more important reason that we need to actually get to the treat these two different types of objects differently. I'm going to call the meshes like naked meshes or something. The meshes that are just parented to that scene without having an Object 3D parent. So let's see. I want to just do a quick little experiment here and print out the position of all of these different sort of top level elements here. So I'm going to just comment that out, save the file, and then reload here on the left. Now, if we take a look at the console, what we'll see is, in addition to this scene, this RhinoDoc that we printed, we're going to see a bunch of vectors showing the position of these different children. Now, you might notice all of these positions are 0, 0, 0. This is a bit of a problem for us. If we look at the scene here, we'd expect these positions maybe not to be 0, 0, 0 because they're at different places in the scene. Turns out that this is sort of this is when this actually generally when Three.js loads geometry, that's kind of what happens. The geometry is located, or each individual mesh is located at 0, and we actually need to transform the geometry so that those positions indicate their true location in space. The reason for this actually and the reason that we actually have to do this, because everything looks pretty good for now, the reason we actually have to do this comes in when we're going to be displacing these different objects. And I think that, I think that maybe let's just go through it now, and then we can maybe you guys just trust me that it's something we need to do. So yeah, and then one other thing, I just have a little thing here. I can show you guys that we can add one of those box helpers to the like I mentioned before, all of these great helpers that Three.js gives us. We can add a little box helper here to show the geometry. And see if we got an issue.
By the way, quick question. What do you need to type into DevTools to look at all the Rhino model metadata?
So the reason we can see that is because I printed it here. If we wanted to see this, we would have to have like a global object called RhinoDoc, and then we could just say console log RhinoDoc. But the way that I'm just viewing that now is just here. Yeah. And yeah, so we'll do this little box here in a second, as we're working on as we're working through transforming this geometry. So yeah, and thanks for the question, by the way. And any questions you guys have, please feel free to just shout them out like that. I think it's good for this to be somewhat of a conversation. It'll let me know that you guys are still there. So anyway, so yeah, so we can just create that box and then visualize it. So now we see we have these cyan boxes here around each of our around some of our objects. These are, remember, these are just the sort of naked meshes without any that are not parented to the another object 3D between them and the RhinoDoc. So let's just move along a little bit here. So what we want to do is, instead of having these objects located at the origin, we actually want to transform their geometry so that they're located at the sort of center point of this bounding box. Of course, if you guys in your apps wanted to make this location the corner or some other kind of origin point, you could use the same exact process for doing that. So what we're going to do here is we're going to create a new translation, and we're going to translate these different geometry from the origin to the center of their bounding box. So that's what we're doing here. We're saying box.getCenter, box set from object child. So that child is going to be this piece of geometry. We're going to get the center, and it's going to set this new vector to be that center, and we're going to subtract it from 0, and then we're going to translate the geometry using geometry.translate. Now, all of this stuff involves linear algebra and is pretty tough. That's why we're using Three.js, and it makes it so simple. So if you just know know the API, or just know the sort of general thing that you need to do, translate. We want to translate this geometry. Okay, we're going to say period translate. So Three.js is doing a lot of work for us to make this a lot easier, and I'm very thankful for it. Okay, so, and then we're going to have to do something similar but slightly different for the objects that are parented to an object 3D instead of directly to the RhinoDoc. So let's save this and reload, and then we're going to take a look at the positions of our geometry here. And we're going to say that all of these are now not 0, but they're locations in our scene that correspond to the centers of those geometry. And this is going to be really helpful when we want to calculate the way that we want to displace these. And yeah, it's going to be good. Another really big reason why you want to do this is if you want to do any kind of rotation. If you want to rotate your objects, I'm sure you guys have experienced this before, but rotating on an origin point that's not central to the object, and you're going to start rotating all the way, you know, around that other point, and it's not going to be what you expected or wanted. Okay, great. So yeah, so I think that does it for loading geometry. Yeah, so we can bring in, using Luis's 3DM loader, we can bring in geometry from a Rhino file, from a 3DM file. We can actually access properties and use them to modify the geometry, or modify the way that the geometry is rendered, or modify the geometry if you want to. And then we'll center this geometry on their individual bounding boxes. So that's going to help us down the road. So that's somewhat it's somewhat a pain, but I think we made it through. One big thing that has been in the past tough for me is all of the array functions that are happening in here, and the scene traversals. So, and there are a couple of conditions that maybe I'll point out. So, well, really mainly one here, which is this child dot unique identifier not equal to the object unique identifier. And basically what this is, this traverse function is really useful. It'll go through all of the different children in our scene graph of the element child here, or whatever you call it on. One thing is, though, it will call it on itself. So you need to be aware of that when you're actually using the traverse function to modify your geometry. Okay. Okay, great. So yeah, so this is the nitty gritty of loading a Rhino model and getting the geometry all set up for stuff later. I am going to just I'm going to just comment this out so we're not getting these beautiful cyan boxes, and we can see our geometry a little better. Now, one thing is, you guys have noticed, as I'm trying to work here, I keep trying to click around and see the other side of my model. I'm so used to being able to do that in the 3D viewer. So we really need to get the orbit controls hooked up here. And luckily, that is really easy. So we're just going to do that now. Before we get into that, does anybody have any other sort of questions or anything that they want to say or hear about more with model loading from a Rhino model?
Nick, I have a question. You guys hear me?
Yeah.
I might miss, I need to step out from my desk. Do you explain when you load the model from Rhino, is the geometry coordination like XYZs? Is there anywhere that you are making mapping? You know, in Three.js is Y is usually up, Z, and the, you know, there is Y and Z is this has the opposite, and then X has to be minus X or something. What we basically do our own uploader. Do you handle anywhere in this problem?
Yes, so thank you for asking that. And I forgot to mention, you do need to set the default up here. And this line here will coordinate the axes in Rhino with the axes in Three.js, or rather coordinate the coordinate system in Three.js with the one in Rhino.
Well, thank you very much.
Yeah,
I appreciate it.
Yep. Thanks for the question. I should have mentioned that. Anybody else? Okay, let's keep going. Orbit controls, fun stuff, powerful and easy. We like it. So, yeah. So the first thing so what orbit controls are going to do is they're going to allow us, like I said, to click and drag around. We can move the camera. So pretty simple. I think you guys all understand what that means. First thing we need to do, like I said, we're loading it from unpackaged from this CDN. So we have it all loaded in. Second thing we're going to do is we're actually going to create our new orbit controls object here. So, and then we're going to update it immediately. So I set this up so we can go like this. Okay, so our orbit controls are going to control the camera position. So we need to be updating them every time we update where the camera goes, or the canvas in this instance. So that's really the only tricky thing with orbit controls, is just knowing where to update them. Once we brought them in and we've attached them or attached our camera to them, we just need to know where we want to actually update them. So we'll update them if we resize the canvas. We'll update them every time we we animate or render a new frame. And I think that's really it. Oh yeah, so one additional thing. So there's a little function in here that I haven't mentioned yet. It's called zoom to scene, and basically what it does is it takes our camera and points it at the objects that we just loaded in. I call this in the load object function, or yeah, and that yeah, it does exactly what it said. Just points our camera to the scene. So instead of us pointing the camera into the scene, what we're going to do is we're going to let the controls handle that for us, and then we're going to update the controls. So let's save this. So really, I don't know, this is like 6 lines of code in a couple different places, but that is it for our orbit controls. And it's really a real pleasure to work with and get in here. So yeah, so now I can click and drag and look at the different pieces of our model, and now we can really see. Now we can actually see better where that origin is. So it's like right on top of that floor. Yeah. Okay, cool. So
I have a Rhino question, sorry.
Of course, go for it.
So the Rhino file that's being referenced, is there a listener here that's kind of watching for that Rhino file for any changes and immediately updating or re-triggering the load method?
No, there is not. That would be a really interesting thing to implement, but there's nothing like that here. It's just loading it once, and then we're going to operate on it. Okay. Now I'm thinking about how to implement that. Anyway, that sounds like a fun project. Yeah, cool. Any other questions about anything? Okay, great. So orbit controls are done. That was like the easiest thing. And yeah, makes me happy. Okay, great. Number 3 is going to be the actual displacement function. Now, I mean, I think we have time. So I'm actually going to go on a slight tangent now that we can actually orbit around the model. I want to just draw you guys' attention to a place in the code where we set up the lighting, because it's something that is a little bit tricky. And one place is where these 3 helpers really is good for. So if you just search for the comment lighting, it's up line 59. So lighting is obviously a tough part of 3D modeling, 3D rendering generally. But I think it's useful to have a little spot like this where we can just take a look at what some of these individual lights actually do, and then we can kind of like like move them around and show them. So let's just step through each of these, and we'll just do it quickly. I think it's useful. So just take a look at what this ambient light does. Now, looks like it's almost not lighting the scene at all. It is a little bit, and we can bump it up and just show what that looks like. Basically, the ambient light adds just a little bit of light everywhere. So it's this very flat light, no shadows, but it's good for just bringing up the overall lightness of your model without actually casting any shadows or doing any complicated computation at all. Next, we have directional light, which is going to cast a harsh shadow, and we can give it a color and an intensity, and we can add a little helper here to show the size and direction of this light. It actually just, yeah, well, anyway, it'll show what we want to show. So now we can see we have this light here, and if we bump this up a bit, we can actually see the effect a bit better. Yeah, and so now we've got a bit of a blue light, and you can really see what's being affected by that. So then finally, we'll just go back to the setup that we had before and take a look at this hemisphere light. Now this directional light, you'll see it's kind of like it is what it sounds like. It's a light with a location and a direction, and all of these rays of this light are going to be pointing just straight away from it. So it's a very, very simple way to get some shading on your model. The next option here, which is slightly more elegant, is the hemisphere light, and this kind of acts like a it's just it's a dome light, so it provides light but kind of on the top. So now you can kind of see how that's impacting our model. So I thought that this just gave a really just a very clean look with a little bit of shadows. So that's why I set it up this way. I think that there's probably a lot more fun stuff that you guys could do with this. And yeah, it all happens here. Okay, so that's the quick lighting diversion, very quick lighting diversion. We can talk a lot more about that.
Just a quick question on that then.
Yeah.
So you have two hemi-lights there, right? Or are you then,
no.
Is that adding to the scene, or is it actually replacing previous lights? How does that work? You can actually add multiple lights sources to it.
Yep, you can add as many you can add as many lights as your computer can handle.
Right.
You could add more hemisphere lights if you want. I don't know if, there would probably be like diminishing returns, especially depends on where you put them, but yeah, you could add many hemisphere lights, you could add directional lights. One that I don't have here is a point light, and that's, it's also kind of what it sounds like. It's a light source with the rays emanating just out from that point. Yeah. That's more for like interior renderings and stuff like that. Okay.
Is there a notion of like once you've added a component, the ability to control elements, attributes of that component? Like you can switch the light off really quickly, like disable, enable, this kind of stuff. Yeah,
absolutely. And we're going to get into that with the displacement and then modifying some attributes and ways that those objects get displaced. So we're gonna get into that really soon here. Good question. Good question. Cool. So lighting diversion done, and now we'll go on to the really fun stuff. I know I keep saying that. We're going to go on to the displacement. So this is actually where we're going to be making this an animated diagram, not only interactive because we can zoom around it, but also because we can actually move these different elements away from each other like an exploded axon. So number one thing, I just to illustrate the sort of state we're in with this application, I went ahead and disabled the input there. So I'm just going to go over to the index.html and enable that slider for us right now. So just disabled equals true. I'm going to change this to disabled equals false, or you could just delete it either way. And you'll see that Budo actually does reload that first. I'm not entirely sure why, but the slider doesn't look enabled to me, does it? Okay, I'm going to go ahead and just delete this. Yep, okay, great. Now we have an enabled slider. So that's a little bit misleading with that disabled property. Okay, great. So now we have a slider and we can move it around, but it's not going to do anything yet. So yay. Number one thing we need to do is, well, first thing is we need to add an event listener to this slider. So I'm just going to go to line 86 and uncomment that. Here we're actually going to grab this slider, which I've called global displacement, because I like long words. And we're going to add an event listener input. And then we're going to call our function explode diagram. So it's pretty self-explanatory, or at least that line is. Actually, this whole thing is pretty simple. You guys might, yeah. Okay, so let's go take a look at our explode diagram function. First thing to know is when we're dealing with one of these input elements, we can get the value of it by calling e.target or event.target.value. So the target is the actual HTML element that we're operating on, and the value is its position. The general scheme that we're going to be working with here is we want these, so just thinking about the way we want an animated axon or exploded axon to work, is we want everything to sort of go out and then come back into its initial resting position. What we're going to do is we're going to see if we can figure out what a really good direction for these things to go in is, and we're going to move them in that direction based on a percentage value. So that percentage value is going to be coming from this this slider. So as we are, so when this event is fired, when we actually move this, the first thing we want to do is we want to get our Rhino doc. So we're going to take a look at our scene, which is a global object here, and we're going to find our object that has the name Rhino doc. So that's one of the reasons that we gave this object that we loaded in from Rhino a name. If somebody is messing with this slider ahead of loading the doc, we're going to just return. This is something, you know, it's a tiny little thing, but it's a little bit worth noting because when we're loading 3D models, this is obviously a really small model, but some might take a longer time. And if you guys get into working with Three.js, I think, and especially with some of the models that we deal with on a day-to-day basis, you guys are going to find that you're going to have to explore ways to efficiently load big models. And it's not an easy thing to do. So anyway, important to think about what happens before the model is loaded a little bit and making sure you don't fail for your user. So then, like I said, what we're going to do is actually get a percentage value of the of where we are on the slider, and we're going to use that to displace our objects. One thing that you guys might notice here is user data.explode. So before we're able to actually move these things, we actually have to set up this direction, and we have to so we have to set up the direction. And what we're going to do is we're going to set up a direction and a maximum distance, and we're going to treat that as a percentage. So 0% is we're not moving at all. 100% is we're moving to the full extent of this max. So all we're setting up is a direction and a value for the maximum distance. So where should we set this up? Well, I think the best place is where we loaded in our geometry. So let's go to the load place, the function. What did I call it? Load model. Okay, so here, as we're bringing this geometry in, we're going to calculate a little a displacement vector, a direction that we want to actually move this object in. So let me just put this up here. And I'll flip, just quickly, I'm going to flip back to this slide that I showed you guys, because this does an all right job of, this does an all right job of explaining what we're going to do here. So it's in these two lines of code here, 205 and 204 and 205 and 207. What we're going to do is actually get the center of our scene box. So the scene box is something I actually also declined to mention, but it's just a bounding box to the scene. So just like we set up little where we viewed little scene boxes for each of those meshes, we also set up a scene box that represents the bounding box of our whole scene. And actually, maybe I should just put a little box helper on that so we can see what that looks like. But it's a tight little box around our scene. Okay, great. So next time we reload the page, we'll see that. So we have that scene box, and what we're going to do is we're actually going to subtract. We're going to subtract the position of our object, so that center position. And you'll see here what we can do is we can actually just call child.position, because we've actually already calculated that, as I showed previously. And then we're going to subtract that position of the object from the whole scene's center. We're going to normalize it, which turns it into a vector that goes from 0 to 1. And that's going to really help us when we, that's going to help us in a moment. I'll explain it. And then we multiply by -1. So that will flip this vector to go the opposite direction. So now we have we've set up displacement vectors for each of our objects that goes away from that center. So that's what we want. We want our exploded axon to go out. Obviously, you don't want everything collapsing in. What we're going to do is actually we're gonna make use of the same cool property of Three.js, this user data property. And I mean, really, this is a property of JavaScript, but Three.js has an organized way for people to add data to their models, which I think is really smart, because you don't want people just adding whatever to each of these objects. Anyway, so we have user data, and just like all of that, the Rhino attributes are in there, we can add our own little object. We're going to add an object called explode, and we're going to add a vector and a maximum. So before, when I was talking about the way that this was really going to work, I was saying that we're going to actually treat the distance on that slider as a percentage value. And then we're going to use the maximum, and we're going to sort of interpolate from 0 to the max using that percentage value. Generally, this is something that I found really helpful in a lot of different applications. If you want to map anything to another domain, you normalize it. So you treat it as a value from 0 to 1 or from 0 to 100, like a percentage value. And then you can multiply it by your maximum or whatever the new maximum of the new domain is. So that's what we're going to be doing here. And the cool thing about this is it's going to allow us to like modulate the speed of these things moving and without having like a speed parameter. And kind of like the diagram will explode to a max, and then we can bring it back in. So that's kind of the way we want it to work, and this is the easiest way to accomplish that. Okay, so I think that about does it. Let me just check here if we need anything else. So like I said, we do the explode. So first we will add the event listener. Then we calculate the explode displacement paths, and then we call explode diagram. And we're going to call explode diagram whenever somebody gives input to that slider. Yep, and that's it. That's all we need to do to get this going. So now if I save this and we reload our app here, now first the biggest visual difference you'll see is this blue box. That's that scene box that I added. And so the center of that is where all of these things are going out from. Now when we move our slider here, things are going to go out. And actually that looks pretty nice from without even having to like manually modify these different things. Now, one thing that I would notice is because this floor slab here is kind of located near the center of the scene box, it's not really exploding the way we would want it to. We might want it to stay still or to go up or to go down. And so we can actually look at how to achieve that in a few minutes here. Does anybody, that was a lot of sort of chalk talk and math and stuff. Does anybody have any questions about how we did that and why that was the right thing to do? Or maybe you guys think it was the wrong thing to do?
Presumably, if the children of the Rhino object had like a normal user data value, you could have used that as the vector, right?
Yeah.
But in this case, you just use your like a different positional kind of proxy vector.
Yeah, I mean, yeah. I think that's a great idea. One thing is that and I think that I think that you're right that we could look at a property of the object and find a better way maybe to explode these. The normal would be a property of each individual sort of polygon face here. But maybe that we can take the average of those normals, or maybe we could do something with the orientation of the scene of the bounding box of each of these. But I think that's a really good suggestion to look at the geometry here and maybe come up with a better way to explode these. Cool. Great. So the next thing we're going to do is actually be able to manually set some of these properties and adjust the way that this actually explodes, so that we can actually make a manual adjustment and correct some things if we want it to explode in a different way than what we've automatically calculated. We are about halfway through. Would you all like to take a 5-minute break? How about this? I'd like to take a 5-minute break. So let's just come back at 2:22, 2:23, and we'll get started. All right, thanks, guys.
Thanks. Good idea.
Okay, hi everybody. I think we are ready to get into the next piece of this here. Okay, so let's get into it. So far we've set up our basic Three.js scene. We've loaded in our Rhino model and accessed some of the attributes coming from the Rhino file. We've set up orbit controls, which are very easy, as everybody has seen. And we've set up some displacement and hooked it up to an element in our user interface, so we can create this this exploded diagram. Okay, so the next thing that we want to look at is going to be setting up selection. How do we set it up so that we get to see what's going on and modify what's going on in our scene? And thank you, Joran and Dave, for your help on the chat. It seems like it's super valuable. So thank you guys so much. Great. So what do we want to do here? We want to set up a couple different states. Number one, we want to set up this hover state so that when you have your mouse over an object, you know you can actually interact with it. We want the ability to select, deselect, and then also deselect all of the things in your selection. And then we want to be able to actually modify attributes on those pieces of geometry. So let's get into it. So number one thing we're going to start with here is our event listener. So this is what is going to allow us to actually interact with interact with our website. So you guys already know all about that. We're going to deal with it. The next thing we want to do is initialize some of the objects that we're going to need to actually get our mouse position, set a hover state sets a list of selection objects, and then and actually figure out what we're hovering on. So the way that we're going to do that is by using we're going to be using a Three.js object called a raycaster, and I'm seeing that there's a typo in the code here. There should be a set of parentheses after raycaster there. So what we're going to be doing is using this raycaster and actually using the raycaster to find out what our mouse is hovering over. What is a raycaster? A raycaster is, like I said before, exactly what it sounds like. We're going to cast a ray, so a direction in space, from our camera in this case towards the scene. And I'm going to show you guys how we do that in a moment. We also want to initialize, we need to know where our mouse is. So we're going to initialize a 2D vector, so just X and Y components, and we're going to initialize it to a value way out in outer space. The reason we're going to do that is because if we just initialized it to 0, we would that position would be sitting right in the center of the screen, and it would sort of automatically be hovering over a piece of geometry. So we want to initialize that way out in space, and I'll talk about what this coordinate system for this canvas with our mouse is looks like in a second. The next thing we want to do is set up an array for our selection. So we want to be able to select multiple objects. I don't want to just be able to select one object. I want to be able to select a bunch of objects. So I'm going to use an array. Next thing is we're going to set up an object for hover. So and like, you know, the reasoning before, I think we're only going to be able to hover on one object. So we can just make that a simple JavaScript object. Now you're seeing I'm actually initializing these to some value here, but I'm not I'm not actually initializing the variables themselves. Those are getting initialized up here. So, and this is gonna, you know, because this is a really simple app, we can do this and just let all of our functions have access to these variables. Obviously, in more complicated apps, these will have to get passed around, and we're going to see a little bit how we would do that with the selection object, which we're actually going to want to give. We're going to want to give our context menu access to that. Okay, so we'll see a little bit how to do that later. Okay, so yeah. So the next thing we have to do something. So now we've sort of set up our situation here. We've set up our event listeners, and we've set up these objects that are actually going to hold the hover object and the set of things that we're selecting. So let's find out what we'll do next. Okay, so the way that this is going to work is we're going to have just like our orbit controls, and this is pretty typical of user interface kind of, or actually also video game kind of animation rendering situations where you have these update functions that will update the user interface to the current state. So every frame we're going to update the selection state as well. So let's go take a look at what's involved in this function. So like I said, the way that we're actually going to be checking to see what is being hovered on or potentially selected is by using that ray caster that we set up and casting this ray. So it's really just a vector from our camera, from some position on this canvas representing our camera, and depending on where the mouse is. So we're just throwing this dart out into space, and it's going to go forever and ever, and it's going to hit potentially one of these objects. So what Three.js is going to do for us is it's going to say, when we cast this ray out into space, what are we intersecting? We'll get back to this little chunk of code here in a second. And what we're going to, so the way we're going to do this, and obviously if you have other objects that you've brought in from other models or things that you've created in Three.js, you might want to do this slightly differently. But for the purposes of this app, what we're going to do is we're going to actually find our node called RhinoDoc. So this is all the stuff that we just brought in from that one file. It's all the stuff with the, this is that top level in our scene graph representing all of the geometry from our 3DM file. Yeah, so just like before, we want to check to make sure that this node in our scene graph exists. I'm calling it doc because it came from a Rhino file, but it really maybe it should be called node or something else. Anyway, and then we're gonna see if our ray, this dart that we've thrown out into space, if that is going to intersect with any of the children, any of the geometry that is attached to this RhinoDoc. And this is super great. This intersects. So what this function will return an array of things that our ray. So the first object is going to be the closest to us. It makes sense to me that that's the one that we would consider us to be hovering on. So it makes our lives really easy. So here we're just going to say if the length of this array is 0, so if we've actually intersected something, if this dart that we've thrown out has hit something, then we're going to grab the first element. So that's the closest thing to us. We also want to grab the sort of top level object. So we don't want to, when we cast this ray out, we're going to get any mesh that we hit. We don't want to get some part of one of these objects. We want to get the whole thing. And when we set the properties of this, we want to set the properties on the whole thing. So on this whole top level node of our scene graph is what I mean by the whole thing. So we do a little while loop here to make sure we're actually grabbing that. Then finally, we will do a little traverse of the scene and actually set the material. We'll give it a little emissive color, which is pretty common. You'll see in the Three.js like documentation. This is a really simple way to give a little hover state or a temporary state to these objects. So let's save this, and I think that this will get us part of the way here. So let's see if yeah. So now when we hover on our geometry here, we see that the material changes. It becomes lighter, simulating light coming out of this or emitting from this object. So that's what emissive, that's where that's coming from. Okay. So that is hover. That takes care of our hover state. Now, one thing that I need to mention about this is this coordinate system that we're using. When we call, let's see, when we call this here, set from camera, mouse camera, space that goes from -1 to 1, and the y is flipped. So you'll have -1, 1 all the way up in the top left corner, and 1, -1. Sorry, no, yes, and 1, -1 down the bottom right. Now I get confused because it's confusing. So one thing we can do is we can print this and just check it out. And this is something that I do a lot. So let's just make sure that we all get the right impression of what this is supposed to be. So we go up to this top left here, and we see that it's -1, 1, and bottom right here is 1, -1. So this is pretty unintuitive in some ways. It's just something you have to know. And it's pretty typical of, well, I guess I would say it's pretty I don't know if it's typical of all graphics sort of rendering environments, but definitely on the web, you'll see y is -1 at the top. Great, so we can stop printing that because it's way too much. Basically, the way that this is working, though, is it's just it's getting the relative position of our mouse in this canvas and then mapping it to this -1, 1 domain. So that's all that's doing. So that's just something to keep in mind when you're converting from 2D to this, when you want to use this 2D screen space position to cast array, you use this. It's called normalized device coordinates, -1 to 1. Okay. Okay, so that's that. So we've got hover down. Now we want to get that thing where you can click it and it changes color. Actually, add it to our selection array. Yeah, so let's go make sure that we have the proper event listeners. So yes, so we're using this pointer up listener. Typically I'd use mouse up. Pointer up is working better for me, so I used that. I think there was some clash with the orbit control. So anyway, pointer up for mouse up in this case. So let's go to, yeah, so our mouse up functions right here. So this is going to be called every time we click. You know, we could use the event click. You could use mouse up. We're using pointer up. And I can't exactly remember why we aren't using click, but I never use click. So what we want to do here is actually grab the thing that we may or may not be hovering on. Well, what we're going to do is look at the hover state and either select or deselect based on that hover state. That's a better way to say it. Oh, one thing that I forgot to mention about hovering, which is interesting to note, is that there might be a question about why we're doing it this way, where we have a mouse position that is set by a mouse move event, and then we call this update selection state within our animate function. So, I mean, that might seem a little weird. You might just want to call update selection state within the mouse move. I would definitely recommend against that. The reason is that mouse move function is called very, very frequently, and it can block other processes that are running. So calling the update selection state in the animate function will provide a it's kind of like debouncing, if you guys have heard that, but it'll make sure that this only gets called once every frame and not any more frequently. So it's just a useful thing, and it keeps your app running really smoothly. So yeah, update. So that's why we're doing it that way. If you had a question about that. Okay, so in the case of mouse, so that's why, you know, mouse move, we're just updating the mouse position, and then we're updating the actual selection state elsewhere. In the case of mouse up, you're not like, you know, you're not like putting your mouse up a billion times a second or whatever. So we can just update that selection state here. What we want to do is, like I said, we're going to look at that hover, the current hover state, and make a decision about selecting or not selecting based on it. So there are three states that we want to handle here. We want to handle, is this a new object that we want to select? Is this an object that's already selected that we want to deselect? Or are we not hitting anything and we have stuff selected, so we're going to deselect it all? So, and I think this actually, yeah, so this is already, with the code that we've uncommented already, this is implemented. So just to demonstrate that, like if you select something and you click it again, you deselect it, select something, select a new thing, you've selected a new thing, you can deselect stuff, you can select multiple things and then deselect it all. So those are the three different states that we want to handle. The way that we do that is with our handy dandy array functions. So find index here to see if the object that is the current hover object, if that actually exists in our selection array. If it does, this means that we actually want to deselect it. So we want to take it out of the selection array and we want to change the color back to the normal color that it had before. So that's what this is doing here. So we're going to, yeah, so we're actually going to splice it out of that selection array, and then we're going to change the color back to the original color. And that original color, we're actually going back to those attributes, back to that draw color. So we're setting it all the way back to that original color that it was in the Rhino model. We could, of course, set another property on user data that's like the Three.js color. But we're, in this case, just to keep things simple, I'm going all the way back to the draw color. So if we want, if this is a new object and we actually want to select it, we're going to just get that object we have in hover and push it onto the selection array. It's simple. And then we want to just change the color to this red, this bright red selection color that we've chosen. And then we want to set the hover back to this empty object. Finally, deselecting all. This happens if we don't have anything in the array, in the intersex array. We want to just go back through. Yeah, we want to go through everything that's been selected, and we want to set the color back to the color it was before in the draw color, just like I was talking about previously, and then just set the selection to an empty array. So just by setting the length to 0. One final. Let's see. Oh, yeah. Well, that's all that there is for the mouse up at the moment. All right, yeah. So then the well, I did forget to talk about something with mouse move, but it's fine. So that's all there is to the mouse up. Great. So now what we have is this cool little thing where we can hover, so indicating that we're going to interact. We can click, we can make a selection, and we actually have all of these things getting pushed onto an array. Now, how do we actually make that? So now, and we also have this really cool little contextual menu thing. And what we want to be able to do is actually, we want to edit some of the parameters on these objects using this menu. So this is all hard coded into the index HTML. This is the kind of thing that you would actually want to end up using a framework for. This is all just, like I said, vanilla HTML and CSS. But you know, if this was a larger app, the way that the DOM, which is the tree of HTML elements, and your Three.js scene, in addition to the sort of state of your app, that would all kind of get handled by a framework. You don't need a framework, and we'll look at how to do it without it, but that's kind of where the framework would come in. Okay. Yeah, and I guess one more point on that is that even if you're using a framework in Three.js, all of the Three.js stuff still happens in the canvas, and you don't really, the framework really doesn't have anything to do with the scene graph or anything that's actually being rendered. So you just use it to set variables in very much the same way that we're doing here. So this Axon Viewer.js could actually be, to some extent, with some modifications, could be dropped into a React app or whatever you guys like to use. Okay, cool. Enough about that. Yeah. So what we're going to do is use this great property, this importing and exporting thing that we can do here. This is an ES6 thing, which just means it's like the latest version of JavaScript. I think pretty much everything, all browsers support it now. Anyway, but I really like it. It allows us to kind of treat our JavaScript files as little objects. Like it makes it a little bit more object-oriented in a way. So what we're going to do is we're actually going to export this selection. So selection here, if you guys blanked out momentarily, is our array of selected objects. So pretty self-explanatory. And we're going to export that, and our context menu.js file is actually going to import that. So now we can actually access those values from within context menu.js, and I'm going to just go over there. Okay. So a lot of this code has to do with, well, about half of it has to do with actually just moving this thing around and closing it and stuff. It's not a very big file, so I've tried to sort of front load the stuff that's interesting to us. I mean, I put the main function right up front so you can see what's going on, but then front loaded the stuff that was actually relevant to how we're going to be manipulating objects within a selection array. So just like before, we were looking at first thing we want to do when we're dealing with some of these user interface elements is we want to set up our event listeners. Like I said, this is what would be taken, or some of this would be taken care of by a framework, but anyway, we're not using framework today because we want to focus on Three.js. So we have these three different, maybe we'll just go look at the HTML so you get a sense for what I'm calling each of these things, but it's pretty self-explanatory. We have our displacement. So these three different inputs correspond to X, Y, and Z, and they are our, this is the displacement vector that these things get moved on. Max explode, this is that maximum displacement value that I talked about before, and then display color is actually the color that's being shown here. So this will be pretty fun because we can reach in there and change some of these values. Great. Okay, so the way that we're going to do this, first, we're just going to add event listeners to each of these input elements. Yeah, okay, so we're going to add event listeners to each of these elements, and then we're going to reach into the object and change their value. The first thing, though, is actually we want to, when we select an object and then open up our menu here, we actually want these values to reflect the current values on these properties. So I think that's a good place to start here. So if we just go to this open context menu function, if you go and look at main up at the top of this file, you'll see that when somebody right clicks, they will open this context menu. So show context menu, we set the position of it. I guess here I'm actually logging the selection, and we're actually going to set the state of this menu to the first element in the array. So we're just looking at the first element. So let's go take a look at set menu state, and then we can really see what that looks like. So what we're doing here is we want to actually reach into these objects. So this is, and remember, this is just a single object, the first element in our selection array. just grab that user data, explode vector, vec, it's just what I called it, .x, and we're going to be able to set these values that way. And we can do that with each of these different pieces here. So, and it's really just as simple as that. You just reach into the object, either read it or you can write it. So when we do the any of these like change x value, change y value, change z value of the displacement vector, or change the max explode, or you can change the color. You really just, all you have to do is iterate over all the elements in the selection array and change that value. This might be where you would want to come in with like a separate Three.js color or something like that, so that you weren't necessarily changing the original values from your Rhino file. But it's actually quite simple. So if we want to make this explode farther, if we want to select multiple things and change them all, we can do that. So yeah, changing the color, changing the distance that they explode at, and you can use this to really set up a nice diagram. Okay, so that kind of gets that kind of does it for the selecting and modifying attributes of these elements. I feel like I did that a little bit quickly. Do you guys have any questions on any of that stuff?
Seems like everything is a global variable. Is that kind of accurate in this case? Well, not everything, but lots of,
yeah.
Scope is kind of like, is that the kind of the way it is for JavaScript in general? Because I've heard that I don't code in JavaScript at all.
So no, it really doesn't have to be. It is in this case. One place that you, I mean, I kind of just did that because it's a small app and it makes things easier. One place it might be interesting to take a look at for this context is lighting, this lighting area. So you can actually set up these little closures here, which will make all of so for instance, this hemi light variable that I declare inside of this closure is local to this closure. And the words that we use, these keywords that we use to initialize a variable actually changes the scope here. So let will make it local. Well, actually, it's always kind of local to the scope. So, but yeah, it doesn't have to be global the way I've done it here. I guess one thing to say though, these are only global to this file. So unless I'm actually exporting those variables and importing them in another, so it's still contained within the files themselves.
But for example, just a quick one, like you have the selection defined here as a variable. How are you then querying that in the context menu? I kind of missed that.
Yeah, no problem. So selection here, it's global to this file.
Yeah.
And then all the way at the bottom here, I'm exporting it. So I say export bracket selection. In the context menu at the top, I'm importing it. So import selection from Axon Viewer. Then that just gives me access to this. Yep. And then you can also there are a couple different ways to do this, but yeah, you can set up some aliases or
okay.
This is a really
interesting. So there's no namespace. It's just as long as it's in the same folder, it'll know to look in that file. It's in the same directory, right?
Yeah, you have to tell it, but yeah.
Right. Okay. Cool. Thanks.
Yeah, no problem. Any other questions? Okay, cool. So we have one last feature that I'd like to show you guys about, and it's a really simple one. It's just this screenshot feature. So yeah, and then I think it would be really cool. I have another. It would be really cool if you guys tried maybe loading up some of your own Rhino models. I don't know if you guys have anything handy that you could just plug in here, but it might be interesting to see if we can get any other cool diagrams going. I think that Thornton Tomasetti has set up a little show-off Slack channel. So if you guys wanted to post any cool images that you made using this to that would be awesome. Okay, cool. So screenshot. So this is going to be just about as easy as as our amazing orbit controls. This is not something that's native to Three.js. It's something that I have taken from this Three.js fundamentals website, and he has a really, really good implementation for it. There is one trick to it, which I will tell you guys. So first of all, way we do it, like we've done the other things, set up our event listeners to our event listener on this button here, so that when we click the button, we get a screenshot. Really simple. I am using the click event there. And let's see, screenshot. Okay, so the way we do that is we just save the canvas. We just call canvas to blob and then save it with this name, and we could call it whatever we want to call it. The one trick here, and then yeah, save blob. You can just take a look at that function really quickly. So yeah, it just creates a little link element, turns the object into like a binary file for our that we can look at as a PNG, and downloads it for us. The one trick here is that we need to call render directly before we actually try to save the canvas, because otherwise your canvas will clear and then you won't be able to, you'll just be downloading a blank image if you don't call this right after you've rendered it. So we actually call this outside of the general render loop, the general pattern, and that is why we've sort of set it up here so that animate and render are separate. So if we just go take a look at animate for a second. So if we just take a look at animate, we're doing the render loop where we call a render on every frame, but render is its own function that we can actually also call independently. So that would be really useful if you wanted to give it a different camera, if you wanted to take different, take screenshots from different angles or whatever. Anyway, we'll save this, reload our page, and then we'll be able to, set our diagram to look the way we want it, and save a screenshot, and then post it to Slack.
So I'm guessing.
Go ahead.
I'm sorry, for the units in Rhino, I'm guessing that's something that doesn't really matter because the scene is being mapped based on a bounding box that's just containing all the geometry.
So the units will only matter if you're trying to bring in a couple of different objects that maybe have different units. Then you'll have to convert between them. And so I think like that's kind of what happens. Like, I don't know if you ever try to bring in a CAD file to Revit, and for some reason the units aren't correct. It will basically be mapping, whatever, 12 inches to 12 feet. So in our case, the units are really, all they are it's just a number in coordinate space and then a way to interpret that. So if we bring two models with different units in, then they could end up being distorted. But if you're just dealing with one object, you don't really have to worry about it. That's correct. There is like dimension to this coordinate space here, but that zoom to scene function really just positions the camera so it can see the whole thing.
So you brought up the other objects you're bringing in, and for integrating other formats like FBX, STL, or like opening this whole can of worms, I guess. How does that work in this context? Would there be like a method that's filtering through what you're trying to bring in and doing different things for different formats?
Yes. So yes, that's exactly how you would do it. Three.js provides a lot of really cool loaders. So OBJ, all here. But like you alluded to, you would have to treat them a little bit differently. They're not going to have, an attributes object on an object called user data. The way that they have organized the scene might be a little bit differently. So you would definitely want to have some kind of switch statement looking for each of these different file types and then treat them accordingly.
Got it. Thanks. Yeah, this is really nice. All the format loaders on the Three.js website.
Yep. And obviously Three.js is it's open source. So if you guys write your own, it'd be awesome to contribute it back. Cool. Does anybody else have any questions? Has anybody tried loading up another model? I can show you guys exactly. I mean, I think we already looked past it, but yeah. So if you bring a model into this models directory here, just here, and you load it up, then we'll be able to you'll be able to visualize that as well. I don't know what a really complicated building with Entourage would end up looking like. It might explode, or even trying to explode that geometry might not make any sense, but definitely worth a try.
Sorry, I have a question about the 3DM loading function or whatever is it.
Mm-hmm.
That is load any other user attribute that we can input in Rhino to that model, or it's just reading the geometry data?
That's a really good question. I don't know if you put user user text on your objects in Rhino, if those come through. I would have to. I would think that there would be a pretty good chance of it. You know what? We can actually we can take a look, but the layers do come through, and I think if you put things in groups, that will come through as well. So it's actually quite a lot of information. Yep, so you got a layer index. Yeah, and then regarding the question about if things change, I think that would be a pretty difficult question, but like I said, an interesting thing to pursue. Knowing if two files are the same or different might be tough, and then identifying what about them is different might be tough.
But that user data is coming from Rhino, no?
Mm-hmm.
Okay. Yeah, it seems it's reading the user data, yeah.
Cool. Does anybody have any additional questions or things that they want to share?
So I'm trying to load a different 3DM, and in the Axon Viewer, where loader.load models and then /. Is that the only place that I need to specify the name of the model that I'm trying to load?
Yep.
Okay, so maybe I'm missing something.
Yeah, and if you want like a clean, if you guys have been playing around, you could switch over to that master branch. So check out master to get back to the main branch, which might go a little bit easier. So I'll ask. Go ahead.
No, I'm about to load a model. I'll post it on the Slack channel later.
Awesome. Awesome. So I kind of have a question for the group. Well, yeah, I have a question, and then we'll just go to a couple of wrap-up slides that I have. Have you guys been using Three.js in your firms to develop any kind of model viewers, or is this something that you're just like looking to do? I don't know if anybody's currently doing that.
Yeah, in my case, the main application would be an e-commerce to show the products for clients.
Makes sense.
Yeah, currently we're using things like Unity and Unity and to kind of do analytics and stuff like that. But yeah, I guess there is an interest in developing viewers, but There's also stuff like Hypar and things like this that you know, enable us to bypass that. But I'm interested definitely in kind of learning, diving deeper into Three.js. And even things like D3, like 2D graphics on the web and stuff like this. Yeah, it's all pretty interesting.
Cool.
Yeah. In our case, the main interest is because the PBR materials, because it's quite hard to find a web viewer with good materials. So our hope, or my hope, is to be able to implement a nice looking 3D model in the view with custom interfaces. That's the idea. In that respect, is it do you work it in with the PBR materials? It's an I think it's a big cake. That part of implementing this kind of rendering.
I haven't actually worked with PBR materials too much. I've focused more on like shader development and working with screen space effects for like line drawings and stuff. So I don't really know, but I mean, I know that Three.js provides a lot of tools to work with PBR materials. So it makes sense that that's why you're interested.
Yeah, maybe. Yeah, it's maybe also you have an experience if you have worked with shaders. I mean, because in our case the PBR materials it's synonymous of to having a custom reflections that that is the thing that it gives a good appearance to or at least the ultra realistic appearance to the objects.
Yeah. I mean, that's definitely hard to achieve in any platform, but yeah, Three.js has some tools for that for sure.
Okay.
Cool. Okay, I think we just have a couple of wrap-up slides here. So, like, what's next? I mean, I think that I think people have brought up some really good suggestions about other things that we could do with this app, including, polling our Rhino file to see if anything's changed, finding out some better ways to calculate automatic displacements of our exploding drawing, or improve the visuals with some better rendering. We could also make it a little bit more efficient, and this is more important when it comes to bigger models, obviously, but we could only render when things change. So unlike a video game or something, there's not a lot changing unless the user is giving input. So that's a really good, that's a really easy performance gate improvement that you can make. So only call that render function when the user is giving input and you want to change things. We can do better on our selection. So instead of using a raycaster, there are techniques for actually looking at using the GPU to pick objects. And the way that works is by rendering each of those objects using an ID color, so a separate color to an off-screen canvas, and you can check what color is sitting underneath your mouse and pick the object that way. We could also implement box selection, so like click and drag, so we can select a large number of objects, and we're already set up for that with our selection array. And then also non-photorealistic shaders, including screen space, ambient occlusion, and edge detection, like I had showed a little bit of previously. So some resources that I would recommend: Three.js fundamentals, like I was talking about, and then just the Three.js documentation and examples that are super useful. Also, Google maintains a open source model viewer that might be useful for some of your cases, so you don't have to recreate the wheel. But I still think obviously it's useful to know a little bit about how that is actually done, because you probably find yourself working with some of the pieces under the hood pretty soon. So yeah, so that's it. So we're a little bit under time here. So I can stick around and work with any of you guys if you guys want to try loading up your own models, if you have any problems that need to be changed or problems that need to be troubleshot. But thank you all so much for attending. I hope you guys got something out of it. If you find the code useful, or want to make a contribution, like I don't know if this is going to be something that I'm going to maintain as a project, but it's a nice little boilerplate to get you started with a model viewer. So yeah, I hope you liked it, and yeah, I'm looking forward to maybe connecting outside of this meeting. Thank you guys.